Hi guys, welcome back. In this video, I'm going to discuss with you how to insert data in AVL tree, or you can say how to construct a AVL tree. So the question is, you are supposed to construct AVL tree by inserting the following data. These numbers from left to right. Fine. Okay. Now first of all, what is there? First number is 14. So first insert 14, because starting maybe have empty tree. So just create a node and insert this 14. 14 we have inserted. Fine. Now find out the balance factor of 14 is 0. This is balance. This is the balanced tree. Fine. Next is 17. The where 17 should be inserted. See, AVL tree is first of all it is BST, and second is height of left subtree minus height of right subtree would be either -1, 0 or 1. So where 17 would be inserted. 17 check karo, 17 is greater than 14, so 17 would be inserted here only. Fine. Now check out the balance factor. Balance factor of the 17 is left minus right. Height 0. Height of left is 0 and height of right is 0 minus 1, that is -1. So no need to balance it out. It is already balanced. Now insert this 11. Fine. Now where this 11 would be inserted? 11 is less than 14. So 11 would be inserted to the left of 14. Still this tree is balanced because balance factor of 11 is 0, balance factor of 17 is also 0, balance factor of 14 is height of left subtree minus height of right subtree, that is 1 minus 1, 0. Fine. See, after inserting each and every node, we are supposed to check the balance factor for each node. Fine. Next is 7. Now where 7 would be inserted? 7 check less than 14, less than 11. So 7 would be inserted here only. Now find out the balance factor. Balance factor of 7 is 0. Balance factor of this 11 is 1 minus 0, 1. That is also fine. This balance factor of 17 is 0. Balance factor of 14 is height क्या है इसकी अपनी 1 and 2. Fine. 2 minus 1, 1. So that is also fine. No need to balance it out. Next insert 53. 53 is greater than 14. 53 greater than this 17. So 53 would be inserted here only. Fine. Now also this is balance 0 balance factor, 0 balance factor. Balance factor is 0 minus 1, that is -1. Balance factor of this one is 1 minus 0, that is 1. And balance factor of 14 is 1, 2. Height of left is 2. Height of right is 2, that is 0. Fine. 0, 1 and -1. Okay. Now insert the next element. Next is 4. Now where this 4 would be inserted? 4 is less than 14. 4 is less than 11, 4 is less than 7. So it would be inserted to the left of 7, left side. Fine. Left of 7, this 4 would be inserted. Now check out the balance factor. Balance factor of this 4 is 0. Fine. Balance factor of 7 is 1. Right subtree ki height is 0. 1 minus 0, that is 1. Balance factor of 11 is what? Height of left subtree. Height of left subtree is 1 and 2. 2 minus 0, that is 2. Fine. And this is not either -1, 0 or 1. So this node is a, you can say, critical node. Because of this node, this tree is unbalanced. So before inserting next numbers in this tree, you have to balance it out first of all. Find out. Fine. Okay. Now how to balance out this tree? See, find out why this tree is unbalanced. This tree is unbalanced because of this left insertion and again left insertion. Fine. Left and again left. So you can say this is left rotation, LL rotation. Fine. And how to solve this left rotation में क्या होता है? Only one right rotation. Right matlab like this. Right rotation. Fine. And how that right rotation would be there? This 11 would be pulled down and 7 would go up. Or simple, the shortcut is, see, we are working on these 3 elements, 11, 7 and 4. The median out of these elements, the median element would always be the root, and remaining element would be children of that element. Out of 4, 7 and 11, what is the median element? That is 7 only. So 7 would be the root. और आप ये रूल के अकॉर्डिंग ये याद रख सकते हो, इन द लेफ्ट रोटेशन 2 हैं आपके L और L, तो इन दैट केस 1 राइट रोटेशन वुड बी देयर. फाइन. द ट्री वुड बी 14 would be as it is, 17 would be as it is, 53 would be as it is. Now what is this right rotation? Pull out this, or you can say pull down this 11 to the right side, right rotation. Or median of this one is 7. So 7 would go up, that would become the root. Fine. 11 and 4, that would be the children of this 7. 4 would be to the left of 7 and 11 would be to the right of 7, because it is BST. So greater element would be the in the right side and less element would be the left side. Fine. Now check out the balance factor. 0, 0, 1 minus 1, 0, 0, minus 1, 1, 2, 1, 2, 2 minus 2, 0. This is balanced tree. Now next element to be inserted is this 13. Where 13 is to be inserted? 13 is less than 14. 13 is greater than 7, so it would go to the right part, and 13 is greater than 11, so it would go again to the right part. That is, here 13 would be inserted. Now find out the balance factor of each and every node. Balance factor of 13 is 0, balance factor of 11 is 0 minus 1, that is minus 1. Balance factor of 4 is 0, balance factor of 7 is height of left subtree is 1 minus height of right subtree is 1, 2. That is minus 1. 0, here we have minus 1. See, 14 ka height of left subtree is how much? 1. See, you can't say 1 and 2, that is the height, because you are supposed to go to the leaf node. उसकी height देखनी है आपको. तो यहाँ से लेके 1, यहाँ से लेके यहाँ 2, and from this node to the leaf node 3. 1, 2 and 3. 3 minus 1, 2, 1. So obviously this tree is balanced. Okay. Now next is you have to insert this 12. Now where this 12 would be inserted? This 12 is obviously this less than 14 and greater than 7 and greater than 11, but less than this. So here the 12 would be inserted. Now find out the balance factor. Balance factor of this 12 is 0. This one is 1 minus 0, that is 1. This one is height of left subtree. Is there any element to the left of 11? No. So 0 minus height of right subtree is 1 and 2. That is minus 2. Fine. And that is not possible in AVL tree. Fine. So we will work on this part. This is our critical node, or you can say the unbalanced node, and this node is unbalanced because of first of all this right insertion and then left insertion. So here it is right left rotation. And how to solve this right left rotation? First right rotation, two rotation would be there. First right rotation and then left rotation. Okay. See, first right rotation. How the tree would be constructed? 14, here we have 7, here we have 17, here we have 53, here we have 4. Now first of all right rotation. ठीक है, right rotation इसकी कैसे होगी? Right rotation would be on this part, because we will make it right rotation. Okay, so this 13 would be pulled down and 12 will go up. 7, here we have 11. Now here this 12 would go up and 13 would go there only. Fine. So now this becomes right and right, RR rotation. Still this is unbalanced because the balance factor of 11 is minus 2. Still it is unbalanced and it is having minus 1, it is having 0. Now next part is, first is right rotation, next is left rotation. 2 है अपने R and R, तो 1 left rotation would be there. and the tree would be 14, 17, 53, here we have 7, here we have 4, and do this left rotation. Left rotation means pull down this 11 this side, left side. Then 12 would go up, 12, this side, left side of 12 is 11 and right side is 13. Fine. So this is a balanced tree. Or simple trick is, see, this is right or left rotation. Always you have to take care the median element of these three would be the root, and remaining two elements would be the children. See, you can check out. Out of 11, 12 and 13, which one is the middle element or the median element? Out of 11, 12 and 13, obviously 12. Now see, after two rotation, right and left, we got what? 12 is the root and 11 and 13 would be the children. So it is BST, so you can easily do this. To the left of 12, 11 would be there, and to the right of 12, 13 would be there. This is the simple trick. Find out the median element and that would be the root. Okay. Now this is balanced tree. You can check out by finding the balance factor of each and every node. Fine. Now next you have to insert is this 8. Okay. Now where this 8 would be inserted? Left of 14, 8 is greater than 7, so go to the right part. 8 is less than 12, go to the left part. 8 is less than this 11, go to the left part. This is 8. Fine. Now see, find out the balance factor. After every insertion you are supposed to find out the balance factor. Balance factor of this 8 is 0. Balance factor of this one is 1 minus 0, that is 1. 12 के लिए 1, 2, 2 minus 1, that is 1. Here we have 0 and here we have 1 minus 1, 2 and 3. See, balance factor of 7 is height of left subtree is 1 minus height of right subtree of this 7 is 1, 2 and 3. Fine. 1 minus 3, that is minus 2. See, you can't say ki 1 and 2. You can write height 1 minus 2. You are supposed to check the longest height. Go to the leaf. So 1, 2 and 3, that is minus 2. Fine. So this 7 is now our critical node. Okay. Now why this minus 2? Why this 7 is unbalanced? Find out the reason. Because of this, first of all, this right insertion and then this left insertion. Because of this right and left, this node is unbalanced. So you will work on this part, 7, 12 and 11. Fine. Same, right and left, two rotation would be there. First right rotation, then left rotation. Okay. We have discussed in detail with the help of this case. Now second, the shortcut is what? Just find out the median element out of 7, 12 and 11. What is the median element? 7, 11 or 12? See, 7 के बाद 11 आएगा, then 12 आएगा. ठीक है, in BST, in sorted order. Then what is the median element? Median element is 11. Okay. So 11 would be the root and 7 and 12 would be children of this 11. Okay. Now the tree would be something like this. See, after this the tree would be 14, 17, 53. See, that part is unaffected part. Fine. Now out of this 11 is median, so 11 would be go to the root. Here 11 would be there. Fine. And 7 and 12 are children of this 11. So 7 is children of 11, then 7 obviously would go to the left part because 7 is less than 11, and 12 would go to the right part because 12 is greater than 11. Now where this 4 would go? 4 would go to the left part of 7. See, left part of 7. Here you will write 4. Now where this 13 would go, 13 is to the right of 12. See, check out in this tree, because we are creating this from this only, we are balancing out this tree. So 13 is to the right of 12. Fine. And where this 8 would go? Now check out, 8 is to the left of 11 in this tree. So obviously in this tree the 8 would be to the left of 11, right? Now go to the 11 node having key 11. Now where? To the left of 11, but you can't insert 8 at this place because here is 7 only. So 8 would go to the right of 7. Why so? Because 8 is greater than 7 and this is BST. So you know the rule very well, because the element greater than that node will go to the right of that node. Fine. So this is our BST now, and this is balanced. You can check out this by checking out the balance factor of each and every node. Fine. Okay. Now next inserted element is what? 60. Where the 60 would be inserted? 60, always check out from the root, greater than 14, greater than 17, greater than 53. The 60 would be inserted here only. Fine. Now find out the balance factor. Balance factor of 60 is 0. Balance factor of 53 is 0 minus 1, that is minus 1. 17 is 0 minus 2, that is minus 2. Here we have some problem because it is not minus 1, not 0, not 1. Okay. Now balance factor of each and every is 0, 0, 0. Here we have 0 minus 1 minus 1. Here we have 1 minus 1 0. Here we have 2 minus 2 0. Find out. You will not find out the balance factor of this one because we have this node unbalanced. So you are supposed to balance it out first of all. So you will work on this part. And the 17 is unbalanced because first of all this right insertion, again right insertion, that is RR rotation. RR rotation में क्या होता है? One left rotation would be there. Fine. Like this, 17 would be pulled down, 53 would go up. Or you can say the median element, find out the median element out of these three elements, out of 17, 53 and 60. What is the median element or middle element? 53. 53 would be the root and 17 and 60 would be children of this 53. Now, the tree would be, see, we will draw this tree here only. Fine. This 14, the left subtree would be unaffected. 11, 7, here we have 4, here we have 8, here we have 12, here you have 13. Now, the middle element is 53. 53 would go up, that is 53 becomes the root. 17 and 60 would be the children. 17 is less than 53, so it would go to the left part. 60 would go to the right part. Okay. Now you can check out the balance factor of each and every node, and this tree is balanced. Now insert 19, where 19 would be inserted, greater than 14, less than 53, greater than 17, that is here 19 would be inserted. Fine. So you can find out the balance factor of each and every node, and still this tree is balanced. Fine. Okay. Now 16 would be inserted. Where 16 would be inserted? 16 would be inserted to the left of 17. Here 16 would be inserted. Still this tree is balanced. You can find out the balance factor. 0, 0, 1 minus 1, 0, 1, 2, 2 minus 1, 1, balanced, 0, 0, 0, 0, 2 minus 2, 0, here we have 0, here we have 0 minus 1, 1, here we have 1, 2, 3, 3 minus 1, 2, 3, 3 minus 3 is 0. Okay. Now insert this 20. 20 would be inserted here only, to the right of 19. Now check out the balance factor. The balance factor of 20 is 0. Balance factor of 19 is 0 minus 1, that is minus 1. 16 is 0. 17, 1 minus 2, that is 1 minus 2, that is minus 1. Okay. And balance factor of 53 is what? Balance factor of 53 is height of left subtree. See, 1, 2, but 3 also. Go to the last level after 16. See, 16 is, you can say, at this place only, 16. So height of left subtree is 1, 2 and this 3. The longest height, the longest distance from that node to the, that leaf node you are supposed to go. 3 minus 1, that is minus 2. So this 53 is our critical node, or you can say the unbalanced node. Why this tree is node is unbalanced? Because of left insertion and then right insertion. Okay, you're supposed to find out the reason. So here which rotation would be there? Left and then right. So you would work on this part only, on these 3 nodes, 53, 17 and 19. Okay. Now in left right rotation, how to solve this out? We are supposed to do 2 rotation. First is left, then right. Okay. Left rotation on these 2 elements. Okay. Left rotation means 17 would go below and 19 would go up. 19 यहाँ पे आएगा, 17 यहाँ आएगा. Then it would become left and left. I'll draw. See, 14. Left part is as it is. Okay. 7, 8, 12 and 13. First, see, we have left right, then first rotation would be left rotation. Left rotation, because you are supposed to make it these type of shape to the either LL rotation or RR rotation. So here we can make it LL rotation, because पहले ही अपने पास starting में क्या है L. तो इसको left बनाने के लिए we will pull this 17 below or 19 would go up. Then 53, 19 would go up, 17 would go below. 17 के left में क्या है अपने पास 16, right of 53 we have 60, and to the right of this 20 is to the right of 19. Here we have 20. It is unbalanced still. See, this is having 53 is having the balance factor is 1, 2, 3. 3 minus 1, that is 2. Here we have 2. Okay. Now 17, this would have 0, this would have 1, this would have 1, 2. 2 minus 1, 1. Now it becomes L rotation. Left, LL rotation. See, LL. Fine. LL rotation कैसे solve होती है? You will do 1 right rotation. Right rotation आपकी इन तीनों पे कैसे होगी? You will pull this 53 down and 19 would go up. Then the tree would be 14, 11, 7, 4, 8. Here we have 12. Here we have 13. Now do the right rotation. 53 would go down and 19 would go up. So 19 would become the root. To the right of 19 we will have 53 and 60 would be to the right of 53. Fine. And 19 के left में क्या होगा आपका 17. 17 के left में we have 16. Where this 20 would go? Check out. 20 is to the right of 19. Now check out. Right of 19. You can't insert 20 here. So 20 would be inserted to the left of 53, because 20 is less than 53. Okay. Now this would be our tree. Or simply you can use the shortcut left and right rotation. You are supposed to balance out this part. Find out the median element of these 3 elements. So 17, 19, 53. A median element would be, see, don't check out कि पहले 53 है, then 17, then 19, the median element would be 17. No, it is BST ना, so try to write down that data in sorted order. First 17, then 19, then 53. Now find out the median element. Median element is 19. 19 would become the root. Okay, 17 and 53 would become the children of that node. हमने यही same thing we have done. 19 is the root. Fine. 19 is the root and 17 and 53 are the children of this 19. Fine. Here see, if you don't go this long procedure with this left right means 2 rotation, first left rotation then right rotation, then simply find out the median element, then median element would become the root and remaining 2 elements would become the left and right child of that node. Fine, that is the shortcut. Here 19 is median element, 17 and 53 are child of children of this 19, and then find out the proper place for this remaining element 16 and 20. See, you are supposed to you have to keep in mind that this should be a BST. So like that they see 20, if you want to insert 20, then 20 is to the right of this 19, but in the right of this 19 53 is there. So it's not like you can insert 20 here or maybe 20 to the right of this 19. Find out the proper place for 19, go to the right of 19 and then find out the proper place. 20 ki proper place is to the left of 53 because this is less than 53. Okay. So this is how the data is to be inserted in AVL tree. In the next video I will discuss with you how to delete data from AVL tree. Till then, bye bye, take care.